Welcome to Long Away Acres here in Eastern Tennessee. My name is Jay Marshall, and I'm Global Head of Value Engineering at Physna. If you came here today with machine learning, 3D CAD, digital twin, or other such things on your mind, this probably isn't where you would expect to find it. What I bet you do expect to find here is a lot of heavy equipment. Things like farm tractors, rotary cutters, pickup trucks, utility vehicles, and of course a whole lot of tools. And what do all of those things have in common? Well, they all come off of manufacturing lines. No matter how different those products and manufacturing lines might be, they all start with a 3D CAD model. 3D is at the heart of almost all manufacturing. And what we want to show you in this video series is how new advancements in machine learning and mathematics have made true 3D geometric search and compare possible. This is unlocking new capabilities across manufacturing, procurement, maintenance, and yes, even the supply chain. And the impact of these capabilities can be felt even out here in the fields of Tennessee. So join me today as we introduce you to the core benefits, features, and use cases of Physna, a new cloud-based software that empowers human innovation by connecting the physical and digital worlds. In the 1884 satirical novel Flatland, author Edwin A. Abbott describes a two-dimensional world occupied by geometric figures. The narrator is a square, and that square describes the implications of living a life in only two dimensions. The reader is asked to imagine a vast sheet of paper on which straight lines, triangles, squares, pentagons, and other figures can all move freely on the surface, but without the ability of rising above or sinking below into that third dimension. Now, can you imagine this? Like living in truly a 2D world? Probably not. But in the modern age of compute, how do we tend to interact with our systems of record? We do text searches. We basically match text strings to other text strings. Nowadays, we can even do image searches. But even those images are a series of pixels. Even the most complex systems today are primarily still working on effectively two-dimensional data sets. Things like relational databases or unstructured data like server logs, emails, or PDFs. So why does this matter? Think about the world of virtual reality, augmented reality, or even the metaverse, or digital twin in the context of Industry 4.0. Every ounce of this in 2022 and beyond is centered around 3D. So let me ask you this. How do you search for it? How do you search the vast array of 3D models in your own environment, or the world for that matter, based on other 3D assets? The answer is, you don't. You do 2D text searches on 3D models that you hope have associations with the same or similar text that you're searching for. Now, this might be through a database, a bill of materials, attributes or properties on the CAD model or in a PLM system, but you're not doing true three-dimensional searching and comparing of the 3D objects themselves. This is the computational equivalent of living in Flatland. That is why Physna was created. Physna takes existing 3D models and applies machine learning and other advanced mathematics to make them accessible, searchable, and ultimately actionable to a broader range of use cases than you probably previously thought possible with 3D. Right now, those CAD models tend to be leveraged primarily at the concept and design phase of product development, and then obviously to help define manufacturing. But what about the rest of manufacturing? Procurement, production, maintenance, warehousing, logistics, and the supply chain. From design onward, we're using 2D mechanisms to search and connect things upstream. Things like part numbers or SKUs, that part number ABC in one system might be XYZ in another system for the exact same part. So right off the bat, we're already adding layers of abstraction from the time the part is created. And that doesn't get into the vast opportunity for human error, as other text attributes get applied to the CAD model itself or within the various PLM, ERP, MRO, or other systems. All in ultimately, it's the part, assembly, or product that we really care about, even at the very beginning during the design phase. Every single day, manufacturing and design firms spend countless hours trying to find existing 3D models because they can't search and compare in their native 3D format. Not just shape searching, but the actual 3D format. Some customers have told us that as much as 15% or more of their designers' time is wasted searching for existing designs. They know that there's huge savings to be had if they can start with an existing part or leverage existing parts in their assemblies. So those savings are obviously great, but the time searching is weeks, if not months, of productivity lost every single year. And many times they never do find a match, which leads to redesigning models from scratch and even creating duplicates when they could have just used the one that already existed. Physna helps eliminate that waste through fast and true geometric search and compare. But it's not just at the design stage. Procurement often ends up buying duplicate parts and products, again not realizing part ABC is the same as part XYZ, because maybe they were purchased from different suppliers, or maybe for different purposes. This means higher levels of inventory, which has downstream impacts like warehousing space or even having to pay taxes on that excess inventory at year's end. And with the recent supply chain crisis, many times procurement teams simply can't even find the parts that they need. Physna allows these teams to leverage the actual 3D geometry of the desired parts to find alternatives that they maybe never even knew existed. And then during the actual manufacturing phase, equipment goes down all the time. And our larger customers tell us that every time a machine goes down, and even after they've found the faulty part, it can take from 15 minutes to many hours to identify exactly which part it is and where it's located for replacement. Phyzna's 2D to 3D photo search capability allows you to simply take a photo of that part, and Physna will match it to the original 3D CAD model and help return the location of that part to help your maintenance teams get the replacements in near real time. And this isn't just computer vision, where you're training a model with 1 million cat photos so that your mobile app can identify a cat when you take a picture. We apply deep learning techniques to the data we extract during our introspection of those 3D CAD models to bring this capability to life, all of which can cut the time finding replacement parts, or maybe even alternative parts, in half or more during the maintenance process. This results in less downtime and therefore higher output and productivity. Physna eliminates all of this waste by using each 3D model's unique object geometry to index your data in a way that makes every model easy to search and easy to find. Physna technology takes virtually any CAD file and creates what is effectively a unique digital fingerprint of that model's geometric attributes. We tend to refer to this as the 3D model's Physna DNA, or PNA. And just like every human has their own DNA, every geometric object has its own PNA. And so once we've ingested and indexed a full 3D data set, you can now perform full 3D search and compare on your entire repository of 3D assets, even parts embedded inside of other parts, embedded inside of other parts. No bill of materials, no parts lists, just pure geometry. This means less time hunting and more time developing products and services for your customers. So in addition to some of the use cases mentioned earlier, imagine all of the new value that this unlocks in those worlds of virtual and augmented reality, or digital twin, and especially digital threads, where that PNA can be referenced and traced anywhere in the manufacturing process, from concept and design through logistics and supply chains. We'll be diving into this and a whole lot more throughout this video series. And we'll be doing it by illustrating how all this equipment around here would likely be represented on the manufacturing floor. We'll be breaking the equipment down to illustrate how different machines and different parts from different manufacturers and different CAD packages can all be brought together under one roof and searched, optimized, classified, and managed in your Physna environment. In the process, we can help reduce complexity, improve productivity, and save you money. Whether you're a manufacturer of a small weed trimmer or delivering large industrial farm equipment. We'll also be illustrating the advanced features I mentioned like 2D to 3D photo search, and even the Physna Augmented Reality Viewer, which allows you to build AR experiences based on those same 3D models with no additional tools, no additional skills, and no hardware. Just a browser and your cell phone. So thanks for joining me today on this little introductory journey around Physna, and we look forward to seeing you in future episodes. To learn more, visit Physna.com and join us on the social media channels listed right here. We're excited to join you on this exciting journey to true 3D digital transformation. So please reach out. Have a great day.